Hello everyone, welcome back. So today we will be entering chapter 12, which is on heat conduction and thermal expansion. So there's two subtopics in this chapter. The first subtopic is heat conduction. So in this subtopic, you should be able to define what is heat conduction, solve problems related to rate of heat transfer. So we will be only focusing on a maximum of two insulated objects in series, and then you should also be able to discuss the graphs of temperature against distance for heat conduction through both insulated and non-insulated rods. Again, maximum two rods in series lah. Right, so what is temperature? Well, that temperature is defined as a fundamental quantity that measures the degree of hotness of a body. For example, if our body is above 37.5 degrees Celsius, it is classified as a fever lah. We are having a fever. If it's less than that, then it is normal. But if it's less than 34 degrees Celsius, that means we're dead, I think. Okay, so it is a scalar quantity with the unit of degree Celsius. Heat, on the other hand, is defined as the energy that is transferred from one body to another because of a difference in temperature. So it only occurs due to a difference in temperature. And then it always transfers from a hot region to a cool region until thermal equilibrium is achieved. Okay, so it always goes from a higher temperature to a lower temperature. Okay, so rate of heat flow. So let's consider this heat conduction through a lag rod, as this one shown here. So it has a cross-sectional area of A and length dx. It shouldn't be shown below. It shouldn't. Okay, never mind. So heat can only flow through the cross-sectional area from higher temperature region to a lower temperature. So only assuming there is no heat loss to the surroundings. Okay, ideally it will only transfers from T1 to T2 because this is hotter and then this is cooler. Okay, so the rate of heat flow, when the rod is in steady condition, so when it is in steady condition, the rate of heat flow is constant along the rod. Okay, make sure you get that point here because usually they will ask you, the problem will include steady condition punya state lah, right? So the rate of heat flow through the rod depends on three factors. So the first factor is the cross-sectional area. Well, basically the rate of heat flow is directly proportional to the cross-sectional area, and then directly proportional to the temperature gradient through the cross-sectional area, and then it is also dependent upon the type of material. Okay, the type of material made the rod, type of material of the rod. Okay, so the relationship between the rate of heat flow and the first two factors are given by the one shown here. So mathematically it can be written as this one. Okay, right, so actually this one should be T2 minus T1 ataupun T final minus T1. Yeah, TF minus T initial. Right? Okay, so the negative sign here indicates that heat is always in the direction of decreasing temperature. Okay, so when you get a negative value here, it will come across this negative, so the rate of heat flow will then be positive lah. Okay, alright. It is a scalar quantity with the unit of watt ataupun joule per second. Right, thermal conductivity K, it is a property of conducting material where good conductors will have higher values of K. Okay, so the higher the value of K, it is telling us that it is a good conductor lah. Okay, so it is defined as the rate of heat flows of perpendicularly through the unit cross-sectional area of a solid per unit temperature gradient along the direction of heat flow. Okay, so mathematically it can be written as shown here. So it is a scalar quantity with the unit of watt per meter per Kelvin or watt per meter per degree Celsius. So in this chapter, 1 Kelvin is equal to 1 degree Celsius. So there is no need for you to change ataupun change the temperature into degree Celsius ataupun into Kelvin. No need lah. Okay. So some of the values of thermal conductivity are shown below. So it can be seen that wood is the most poor conductor among the substance shown here lah. Okay, now temperature gradient pula, it is defined as the temperature difference per unit length. Okay, per unit length. So the unit is Kelvin per meter ataupun Kelvin per degree Celsius. So this is the type of metal bar. So one of it is unlag ataupun lag composite metal bar. In this case, this one has two types of material. This one only has one type of material. This one type of material without any insulator. Okay, so metal bar XY here is not covered with an insulator, meaning that heat will be lost to the surroundings because it is not insulated. So the heat is being transferred from X to Y, causing the temperature gradient to gradually decreases along the bar. So that's why we have this graph shown here, because as it goes from X to Y, the temperature decreases along the rod lah. Okay, so it results a curved graph where the temperature gradient at X is higher than at Y. Okay, so it can be written as shown here, where the area and the thermal conductivity are the same along the rod lah. Okay, like metal bar pula. So this metal bar XY is completely covered with a good insulator, meaning that there is no heat will be lost to the surroundings, causing the temperature gradient to be constant. Ideally, it will be constant lah. Okay, but in reality, we can't actually get this type of situation lah. Okay, so dq over dt, which is the alright, wait, it should be, let me double check it. I think it should be dq over dt over x, because this is talking about the temperature gradient. This one as well. If it's wrong, then you'll get the updated punya lecture note lah. Right, so the temperature gradient along the road will be constant, hence we have this type of graph lah. Okay, now we have the lag composite metal bar. So this one, the rod is again covered with the insulator, with a good insulator, and then there's two types of material C and material D. So again, this thermal conductivity will not be the same for both materials, since there are two types of materials. So when steady state has been achieved, the rate of heat flow through both materials are the same. So from the equation of thermal conductivity, which is this one, we can actually say that the temperature gradient at material D here is greater than the temperature gradient along material C. Alright, so for this graph, it is advisable that you are able to draw this for all three types of bar, because last time there is a question asking the student to draw a graph showing, I think it's this one punya graph. Okay, so just make sure you are able to draw this graph lah. Alright, so that is on subtopic 12.1.